people's asked, why we're going over drill piers again. Answer your question. Because we seem to keep having the same issues over and over again. Common problems that we see with drill piers throughout the state. You got layout issues, pre-drill meetings. I'm on phone. Most people talk with their hands. I got to talk and walk, so I'll probably fall down up here as much as I can. Pre-drill meetings, drilling inspection procedures and documentation, 4-day inspections, and then after the shaft is complete. Guys, we're seeing issues in all these items noted here. It's not just one particular thing. I ain't going to go out on layout a whole lot since we talked about it this morning. Main thing here is, guys, is when you start drilling your shafts, first thing that goes in is either permanent casing or temporary casing. Your contractor comes in here and etches these casings, either a rock tooth or with a hacksaw blade or whatever. Well, if he's doing his drilling, what happens to those casings? They get bumped, they get moved, etc. I highly recommend that before you pour, definitely before you pour, that you shoot that line back in. Okay? Because if you start this off wrong, it's a pain in the butt to fix. Pain in the butt to fix. Common layout issues. Drill shaft location staked prior to pre-drill meeting. Again, contract survey and the contractor staked it. The bottom thing here is the biggest thing. When we set batter boards in, we're down there drilling, you got tools laying everywhere, you got spoil piles laying everywhere, you got a lot of stuff going on in a small area. Well, before you know it, those batter boards get hit. Well, Joe Foreman goes down there and sets them back in, and he's not the smartest tool in the shed, and next thing we know, we got a shaft off 3 foot or whatever. So, that's very common. That's very common. What are our responsibilities? Permanent casings may be required. And all this is going back to what we talked about over here. Permanent casings may be required. Anybody ever saw that in their plans? What that means is during the design phase that Geotech or structures thought that we might need permanent casings in here because they was looking at the relationship of the shafts in relationship to the creek. Well, this project was designed 3 or 4 years earlier. For the last few summers, we had a drought. So, that creek alignment could have shifted, it could have decreased. So, there's a possibility that we might not need permanent casing. Big thing here is you need to lay out these drill shafts prior to the pre-drill meeting. That's what we need to do. Every time I get a phone call and say, Lee, we need to schedule a pre-drill meeting. First thing I ask you is, 1, is the drilling plan approved? 2, have you got permanent casings, and if so, are they required or may be required? If you tell me may be required, I want them to stay. Because here's when I'm going to start making that decision. Again, contract survey is in the contract. We need to check it prior to beginning construction. Bottom line right here, guys, is be right. Be right. Because this is the foundation of our brick. If anybody's got kids in here and ever went and played in the floor with your kids and you start doing building blocks, if you don't have a good foundation, and you get so far up, what's going to happen? On the fall, wing. So this is the foundation of our bridge. This is what it all goes down to. So be right. Why? Right here. Good layouts or correct layouts are a critical step that will make us make good engineering decisions, providing a good sound structure. Pre-drill meeting. Everybody here ever attended a pre-drill meeting? This is something that needs to occur prior to drill. It's not just put in the special provisions for us, to read about it, when we want to read. Bottom line is this needs to acquire or actually happen prior to drilling. First thing that needs to happen is the contractor needs to submit his drilling sequence plan. I've had people call me up, Lee, we need to have a pre-drill meeting. Contractor's on site. My first question has his plan been approved? Believe it or not, I've been told sometimes, no, it hasn't. So we have to push it back. This is our first line of seeing how he's going to drill this hole. So if we don't agree with how he's going to drill this hole, this is when we can start I wouldn't say rejecting, but talking about how he's gonna drill a hole. Start talking to him. But we need to have that plan approved prior to the meeting. Second thing with this plan, got a couple of residents in here, got a couple of assistant residents in here. I'm gonna pick on you a minute. Don't know if you do it, whatever. This plan needs to be in the inspector's hand or in the inspector's truck. It don't need to be stuck in a file cabinet in the office. Because when Darren or myself go out on a job and we're having issues and we're like, well, how did he propose to drill this? Or what kind of tool was he going to use? And, we're like, what does the plan say? I don't have it, it's in the office. Well, that does us no good because we're an hour from the office. So, residents, assistants, give us a plan to your inspector because he needs it. Second thing prior to the meeting, who needs to attend? Who needs to attend? And again, guys, I'm just telling you some things that have happened a lot to me with other guys here. I've got calls on the morning of the pre-drill. Lee, we're having a pre-drill meeting at 11 o'clock. I'm in Avery County. This is in Rowan County. I'm just using that as an example. More than likely, I'm not going to get from Avery County to Rowan County by 11 o'clock. So, give us a chance to attend. Give us a chance to attend. Because we want to attend. Believe you me, we want to attend. There's going to be sometimes we can't. Give us a chance. That don't mean call the day before either. At 5 o'clock, I got a pre-drill meeting in the morning at 8. So, give us a holler. But the people that I would like to see there, Resin Engineer. Why? You need to be there? Because it's all going to fall on your back. You're going to get blamed for everything. So you need to be there to hear what we're all talking about. Assistant resident, it's nice for you to be there because you're there more so than a resident. Inspector. And I emphasize the inspector here, the one who's actually going to be watching the drilling going on. This is your chance to hear from the resident, from us, from the contractor, from the drilling contractor, of how we're going to start drilling these holes. This is where that communication starts. These are where your problems or concerns start being addressed. So if you're going to be the inspector on the drilling operation, you need to be there, if you can. There's going to be some instances that you can't. But it's nice for you to be there so you're hearing everything that's going on. Because you can look at Eddie or Henry and say, this is what was said at that day. Why are you going 180 degrees different? That ain't what we talked about. The BCE, again, we want to attend if possible. The Geotech folks, Dean Hardister was here this morning. Chris Crowder, who is his counterpart. I would highly suggest that one of us or them be at a meeting. Sometimes we can both be there, sometimes we can't. But one or the other needs to be there because there's some issues that's going on with soil borings, drilling operations that, I'm not saying that we're smarter, it's just that we've seen more and more stuff happen that we can kind of address as the drilling contractor brings it up. So it's nice to have as many tools as you can there to help you answer the questions. The prime contractor. Why does the prime contractor need to be there? He's over everything, exactly. I've been on some prime contractor hadn't been there, and the first issue comes up is handling the spoil pipe. The drilling man says, well, I ain't got nothing to do with spoil pipe. It's the prime contractor's responsibility. He needs to come there and get them up. But then here we are arguing about what's happening with erosion control issues, and the prime contractor ain't nowhere to be found. So he needs to be there to hear what's going to happen, or what needs to happen. The concerns that we have with erosion issues. So he needs to be there. I got this right here in red because this right here is the critical thing you need to remember. And those who have worked with me before have heard me say this. The drilling contractor superintendent, it's nice for him to be there. But the man's going to be doing the drilling operations and overseeing that, he definitely needs to be there. He definitely needs to be there. Anybody here ever worked with McKinney Drilling? Who comes to their pre-drill meeting? John May? John May. John May have drilled your hole? No. Exactly. John May's going to tell you everything you want to hear. Yes, sir, I can do that. Yes, sir, I can do this. Who's going to drill this hole? Exactly. Henry, somebody else maybe. Dale Simpson. So you need those two there. One's going to drill your hole so he can tell you how he's going to approach it. Because Johnny Mays is gonna tell you what you wanna hear. Well, when Henry comes out there, Henry's like, I ain't gonna drill that hole that way. And then you're back to square one. You're back to, well, I won't say arguing, but you're back to having some disagreements. So, residents, assistants, the time that I would start thinking about this pre-drill meeting is when they start mobilizing to the job. Because the man that's sitting there putting the equipment together is more than likely going to be the man going to be drilling your hole. So, don't call up and schedule a pre-drill meeting 3 weeks before drilling starts. Because you're not going to get that guy there more than likely. And if he's there, he can hear what we're saying. He can tell us what he has to say. And that's just preventing issues and potential problems from arising when drilling starts. Right here, again, meeting must be held prior to drilling operation. I've had people call me up, Lee, I forgot to hold a meeting. We're drilling. Do we need to hold a meeting now? I'm like, well, it's too late. Too late. Prior to the drilling. Again, we talked about this. Need to have a plan on site. Permanent casings. Layout each shaft for permanent casings are questioned. Got a contractor guy who loves to sell you permanent casings. He loves to sell you permanent casings. That's how he wants to drill a hole. He wants to stick a permanent casing down the rock. He wants to go inside that rock and start drilling. He don't want to telescope any casings. He will sell you a permanent casing if you're 50 foot from the creek. I've seen it. I've seen him do it before. I scratched my head about what happened, but he done it. Stake them out prior to the meeting and we can address that then. Okay? And again, schedule a meeting for everybody to attend if you can. Wise. Drilling inspection and documentation. We've had the pre-drill meeting. We're starting to drill now. We're starting to drill. We're actually starting to work. Anybody ever seen this form right here? Fill it out. Where do you put your information when you're drilling a hole? Put it on this form. Put it over here and that. Workbook. Guys, this form is nice. This form is nice. It's got all the information we need. But more than likely, when me and Darren walk out on a hole and say, Jody, what's static water level, elevation? I'm not saying you've ever done this. I'm just using an example. And Jody's like, well, I don't know. It's on the paper in my truck. And, I'm like, okay. Jody, what's the length of that casing? Well, I don't know. It's in my truck. But when you're pouring the holes, guys, you're going to need to know all that information when the hole is getting poured. Because if you don't know, that could cause problems. You need to have it handy. I recommend putting it in this workbook. I saw one over here on this desk this morning. I don't know if you still got it. You still got it? You know what makes this so handy? If you drop it on the floor, kick it, drop it in mud, it don't matter. This is yours. This is yours. You know what happens to this book? Conveniently goes in your back pocket. It's pretty good back there. It won't fall out. That piece of paper, normally it's going to get lost. That workbook won't. So use that workbook, guys. Use that workbook. When we get done drilling the hole, then we can put it on this. This workbook can stay with you from the day the drilling starts to the day the drilling ends. I got a guy down in Division 9. He's been around me enough to know that when I walk out on the job, I'm going to start asking questions. And I got tickled at him the other day. I walked out and started asking questions. He had a notebook and flicked it out just like he was policeman getting ready to give me a ticket. And he just started naming all these numbers off. And I'm like, you know what? You can pay her in. What I like to see. What are our responsibilities? One is inspection. Next thing is documentation. Guys, both of these are equally important. One ain't more important than the other. You can inspect it, but if you don't document it, most everybody here probably got good memory. I think I got a good memory. But sometimes I forget. Sometimes I forget. Everybody here forgets. Document it down. Document it down. Okay? What do we do on inspection when we start drilling these holes? I recommend, and you've heard me say this in the class before, you've heard me say it during drilling operations. When you're sitting there and it's a slow day, watching a man drill a hole, especially if he's in hard rock, it's about like watching grass grow. It's boring. It's boring. But get out these bore locks. Start reviewing. Start reviewing. The reason I say that is There's been very few occasions that I went out on the site and actually hit what Geotech says I was going to hit and when I was going to hit. That's what that shaft was designed for. Now, they anticipate you hitting rock at elevation 900. You might not hit it till elevation 880. Well, you know, they're anticipating that rock up here, and you're not hitting it down here, so you losing that lateral stability that Dean was talking about. So if that happens, you need to know that, and you need to get on the phone. You need to be calling your assistant resident. Assistant, you need to be calling your resident. Resident, you need to be calling us. Because we might have to lengthen that shaft. We might have to lengthen that shaft because we lost that lateral stability. But if you're not there prepared to know what's going on, we won't know. We won't know. We won't know. So review the boring log, because that's what that shaft was designed on. When they're drilling, again, it's like watching grass grow. Look at what they bring out of the hole. I mean, that's going to verify that if rock was at elevation 900, when they get to 900, you should start seeing either coal barrels going in, etc., chunks of rock coming out, rock cuttings coming out. Now, if you got a downhole hammer, it might be different. You know, we're going to have to talk about if you got a downhole hammer on your job. But there, you're verifying what you see here. Right there is your verification of what the board log say. Okay? You need to be looking at it. You don't need to be up in your truck listening to whatever on the radio or doing a Sudoku puzzle. You be looking. Note unusual characteristics from drilling. What I mean by that is if you're drilling and you got a good stream of water coming in at a certain elevation, you need to note that. Because when we're pouring that shaft, if we run a CSL test and we get an anomaly back at that elevation and we're sitting there saying, what's going on? What's going on? Oh yeah, we have a stream of water like that. That's telling us what's happening, so we can make a better decision on what to do to fix it, or if we even have to fix it. So, note those unusual characteristics. If you see a void, like I say, if you have a high water table and you got a not so confident drilling contractor, you start sucking the water out, losing the static water, you start getting blown, and you get big voids. You get big voids down there. Well, when he goes to pour his hole, instead of taking 24 yards of concrete, it takes 44 yards of concrete. And he's like, man, something's wrong. Y'all owe me more money. Well, no, you had a big void down there you could drive a school bus on. So, stuff like that. Check the plumbness of the shaft. As Dean was saying, we design stuff on axial load and lateral load. If you got a shaft that's in there like that, it's not going to take an axial load straight down in. So anyway, you're losing the design of the bridge. Again, your foundation is the start of your bridge, and your bridge is only as good as your foundation. So get it right. This last note right here. Note machine reactions to different types of soil. We got honest drilling contractors, don't we? Honest as the day is long. I dare say if anybody's ever been around a shaft has not questioned if you've got gypped on rock or not. If you're noting those machine reactions, you're going to train yourself if he's pulling your leg or not. So if he goes out there and he's drilling dirt 3 feet in 5 minutes, and he hits rock, and you verify rock, and then you leave and come back, and he's back to drilling 5 feet in 2 minutes, and you go down and ask him, he said, no, I'm still in rock. Well, you know what's going on. But train yourself to rock. Train yourself to that, okay? Documentation. Again, like I said, inspection and documentation go hand in hand. One is just as important as another. You're standing there seeing all this going on, but you need to write it down too. I talked about elevations. Where your top of the shaft is, where your bottom of the shaft is, where rock is anticipated, where it's not, etc. You need all that. Links to the shaft. The reason I say links to the shaft, if you ever telescoped the shaft before, or telescoped the casing, you need to know the length of that inner casing. Because when you start pouring that shaft, you need to know when he needs to break that inner casing. Because if you break it too soon, you could potentially have a bad shaft. That's it in a nutshell. So if you don't know the length of that inner casing, and he starts to break it, You have no idea if you broke it too soon or not. The only way you're gonna know that is if you run a CSL test, and we'll get into that in a minute. But if you got an interpretation link, you need to know that link. If I come out on your job, and it's a wet pour, and you got telescope pipe, I'm gonna ask you what the links of those are. And if you don't know, you're not prepared to pour that shaft. You're not prepared. And if you're not prepared, when you call me up the next day and want to know if we need to run a CSL test, I'm going to say yes. And you're going to say, why? I'm not going to tell you you're not prepared. I'm just going to say, well, we just don't know. Because some things went on that I don't feel comfortable with in making the decision that the shaft's good. The diameter of each case, I've never had a contractor do this, but you need to make sure that your casing diameter is the size it needs to be. So if you got a 48-inch shaft, you need to make sure you got a 48-inch case. You don't need to have a 40-inch, okay? You need to verify that, okay? Static water elevation. Guys, I can probably use these front 2 rows here. And use your hands, fingers. At the number of times I've asked what is static water, and people give me the look like I have no clue. I have no clue. That right there is your number 1 culprit, probably, in resulting in a bad shaft or not. And if you don't know what static water elevation is, then you're way, way, way behind the game. So you need to know that. If you know anything about drilling shafts, you need to know what static water elevation is. And I know some of y'all haven't had to drill shafts before, but once you have, static water elevation is what the water rises to in intercation overnight. And when it quits rising, that's your static water. Okay? So you need to know that elevation. You know, you go out there, Dick, I've had some, I say, what's static water? Oh, it's about, I don't know, about 2 foot down the top of this casing. Well, is it 2 foot? Is it 3 foot? Is it 1/2 foot? You know, give me an elevation. We're not building watches, but we're building bridges. We're not doing roadway work. So, water inflow, wet versus dry. What I mean by that, I need to know if it's going to be a wet pour or dry pour. And again, I'm going to use these first 2 rows. This is kind of like static water. I went out on the job, I said, is this going to be a wet pour or dry pour? I don't know. About that time pump truck comes in. I said, well, I guess it's going to be a wet pour. I guess so. So, know if it's going to be a wet pour or dry pour. Because that determines on how you pour. That determines on what slump you run on your concrete. Guys, you are preparing yourself for a test. Because come pour day, that's the test. Because if you're not prepared on pour day, you're going to fail. You're going to fail. Well, I shouldn't say you're going to fail. You put the chances of us succeeding in the contractor's hands. So, and sometimes even you can prepare yourself, and I've been there, and we still fail. But bottom line is you got to prepare yourself for this, okay? Elevation, top of rock. Again here, guys, know where that is. Know where that is. Because if we're hitting rock lower than what we anticipate, we might need to shorten that or lengthen that shaft. But, you know, when you're drilling, once you hit it, if it's higher than what we anticipate, and it's good hammer ringing rock, we might raise the bottom of that shaft. I mean, rock, or it's not called rock, but not in soil, you know, you're going $2,000 a foot, $2,500 a foot. In soil is going for $1,000 a foot. I got a project on I-85 now, it's got 19 bins, got 8 shafts per bin. So you can do the math, 130 some shafts, 150 some shafts. If we hit rock higher than what we anticipate, and we could raise those shafts. See how much money we save? See how much money we save? So, I mean, even if you only got 4 shafts, you still save money. And we all in here win on that because we all taxpayers. But you got to be on your game. Inspection-wise, we kind of went over that. Documentations-wise, 4-day inspection. This is when we get to shine. This is when I see if you prepared yourself. This is when me and Darren get to come out here. Like y'all done all the hard work. It's when we ride out here and we get to see concrete go in the hole. But if we come out here and we start asking you questions and you kind of feel, oh, you know, this and that, and whatever, we're going to be over here wondering, well, you know, have we got a good hole or not? So, this is your test day. Responsibilities during pour. First thing we got to do is we got to verify the bottom cleanness. You can do it in 3 ways. You can inspect it. You can do it with a SID, or you can do an SPT. Here's a SID. Here's a sheet that we fill out for SID inspection. Residents, assistants, if you fill this sheet, or actually fill out a request, you're supposed to call, and she email Blocky and Robin to schedule a SID inspection. In Divisions 9, call me. Call me. Because I've had issues with that. I've had issues with that. And I'll schedule your SID for you. So anyway, just call me. Responsibilities during pour. Workbook accessibility. This is when you need that in your back pocket. This is when you need all that information we just talked about and documented today. Because when we get there, we're going to be asking you all these questions. You got to have them ready. Hopefully you got them up here. But if you don't, at least you got them handy. Okay? But have it accessible. It's nice to talk to your drilling contractor. So you and him's on the same page. Hey Eddie, you're going to break that casing when you get 20 foot of concrete in. Hey Eddie, you're going to break it when you get 15. You know, you're going to pull your outer casing first. You know, you're going to use a trimming pipe. You're going to use a pump truck. You know, talk to them beforehand. Next thing we got to do is we got to test the concrete. Now here's where, you know, I talk to the residents and assistants again. Most of the time on shaft, you might have 1 guy on it. Over the last couple of months, you know, we've been slow. We've had 2 or 3. But back when things were hopping, we probably had only 1 guy on the structure. What do you do when you get a load of concrete on a job site? What's the first thing you do? Take samples out of it? Right. Well, anyway, take it back to it, verify the mix design. But basically, you take a wheelbarrow load of concrete. And Darren will get on you for doing that in a minute. But you run a chase, right? Next thing you're going to run is you're going to run a slump. Then you're going to look at the contractor and say, it's good. And he's going back to that pump truck and he's going to start pulling that shaft. While you up here making your sealing. That's probably what happened. 90% of the time, right? You need
to... If I find myself, I hold them up.
That's what I suggest.
But,
I mean, you're only talking 2 minutes. Because if you're pouring a wet hole, you need to be standing at that shaft looking. Wayne had an issue on his job with a pump truck. It happened right at the start of the pour day. Which y'all told him because y'all were there. Said, hey, I think you got a bad shaft. Well, he elected to continue on pour. We spent how many weeks trying to fix that shaft? A couple months. When in 1 week, it was months. But it's because he was there. He saw it happen. He saw the pump truck jump. And it was only a split second, wasn't it? Yeah. I mean, it was only a split second. Just boom, boom. Just that little bit caused us to lose that shaft. But if he wouldn't have seen it, we might not run the CSL test. Maybe not. Don't know. So, if you're by yourself, hold him up so you can get down there and watch the hole. Okay? Hold him up. Second bullet here. Observe the placement of the trimming pipe hose. You know, Cameron had an issue with this. I've never had this, but make sure your trimming pipe goes all the way to the bottom. If you got a 30-foot hole and you got a 40-foot trimming, you should have 10 foot of trimming sticking out of the hole. You shouldn't have 20. Okay? He needs to be on the bottom of the hole. If he's not, we're going to have problems. So you need to make sure it goes to the bottom. Basically what I like to see is I like to see it go all the way down. Crane line comes loose or slack. And you tighten it up and you pick it up about 6 inches. It'll be good. But you got to watch it. You got to watch it. Be observant when the trimming, this location when the pumping operations begin. I know this while ago with Wayne. This is your second step that will probably cost you a shaft. If you're pumping a wet hole, and you got a pump truck sitting in there, and he throws it to it without picking it up, and that pump truck builds up pressure, it's going to go up, go back down. When that happens, he's induced water into his mix. More than likely, you're gonna have a bad shaft for the first 3 or 4 feet. But if you're not there, you don't see that. And you call me up, or call Darren up, and say, do we need to run a CSL test on this? I mean, I for one would love to come to every drill shaft before you got. I would. I can't. I don't think Darren can. Can you? Make every drill shaft for? So you are our eyes and ears. Your inspections determine if we run a CSL test. Well, I've had some people say, well, we need to run a CSL test on every shaft we do. Maybe, maybe not. But I'm going to tell you something. CSL test, they run about $1,500, $2,000. We do several across the state. Now, I'm just going to throw out numbers. If you got 100 shafts, we have about 5% of defective shafts based on CSL test. So out of that 100 shafts you done, you got 5 that's bad. So take 95 and multiply it by $2,000 a pop. That's how much money you spending that we don't need to spend. If we do our job. If everybody, contractor, us, do our job. So don't use the CSL test as your crutch, okay? It's a nice tool to have, but don't use it as a crutch, okay? You need to be standing by the hole when this stuff's going on. And guys, you're saying, well, Lee, you told me this 100 times. Lee, you told me this 110 times. You told me this 300 times. Guys, I could probably tell everybody another 1,000 times. And we will continue to walk out on the job site and see the same issues. We will. So, anyway, note the elevation required for the removal of the inner casing. That's being prepared, guys. That's being prepared. If you got a 25-foot casing in a hole or an inner casing, and you got water on the outside, you need to know when you can break that casing, okay? Because if you break it too soon, the water on the outside of that casing could weigh more than the concrete on the inside at that point, and you could have water infiltration into that concrete, resulting in an anomaly. Johnny, was you on I-85 at the Davidson Community College project when that happened to us down there? And I say it happens to all of them. I left the drill shaft training class 3 years ago, went directly to a pour, sat down there, and I argued with the contractor for 30 minutes, telling him he don't need to break that case. Argued with him. Because what he done is he made a wet hole dry. He screwed that inner casing in there and stuck it so he could get a dry hole. So when he had to break it, because he had about 30 foot of head, he had to put about 15 foot of concrete in there. And when he done that, he was afraid he was going to get his casing stuck. So he broke it at 10 foot. I showed him the map. I said, it ain't going to work. He done it anyway. He wound up drilling another, or actually 2 shafts beside him, putting the saddle in over. But again, it happens to all of us. But we were there and we knew what was going on. Okay. Why? Again, best thing off this slide right here: be prepared. Be prepared. Be prepared. Shaft completion. Hopefully we poured the shaft and everything's went well. Everything's went well. What do? Well, we can decide if we want a CSL test or not. I leave that up to the resident. I leave it up to the area bridge construction engineer. I leave it up to you. But I can tell you that if you call me or you ask me, I'm not going to tell you to run a CSL test on every shaft we got, unless we got a hammerhead bent with only one shaft in it. That's the only time I'll tell you we have to run a CSL test on every shaft. But if you got a multiple column bent, I'm not going to tell you that, because I think we can use our expertise and save us some money. So we can determine if we need a CSL test. Again, don't use it as your crutch. This is what one looks like when you get sent to you. As you see, you got some loss down here at the bottom, loss up here at the top. But other than that, that's what they look like. The completion of the drill shaft inspection report. Guys, don't wait to the end of the job. If you got a 3-year job or a 2-year job, and you get your structure done in the first year, fill them out and send them to Geotech. Okay? Don't let them sit in the office. Get them to them. Again, why? your observation will determine if we need a CSL test or not, and Geotech needs to report. I got some pictures here of things that I've seen crossing the state. Anybody want to take a gander on what that is? Huh? Pig? Plug? That's a pig. Everybody knows that we got to use a pig if we were doing a wet pour. It basically separates the concrete from the water. That's the concrete's coming down. I drove up on the job site, I saw this right here, and I went to the contractor. I said, Mr. Contractor, I said, I don't think that's going to work. The picture can't depict it, but you can see daylight here and here. I said, when you stick that in the hole, water's going to dislodge every bit of that. You're going to have multiple balls. They're not going to be intact. He's like, oh, no. He says, man, he said, that's fine. He said, that'll work. I said, it won't work. So we argued for about 30 minutes. And so we go to lunch. I was going to be there for lunch. Come back. He took a food line back. Just the old food line, grocery bag, plastic bag. Put it on the end of the trimming pot. Taped it up. I said, you think that's going to, anyway, I go to him again. I said, you think that's going to work? Yeah, man. He said, it's going to work. It's going to work fine. So we're going to get good for it. I said, that pig is supposed to be your bear. I go through the whole process again. Tell him. No. Well, he proceeds to pick his trimming pipe up, sticks it in the hole. At that time, what happens is what I told him was going to happen. It's going to dislodge. You're going to have multiple balls. This ball was the only one that made it to the top. The rest of them, I had no idea where they went. So this only ball here is the only one that I see floating on top. So you see the boards in between that orange ball. I said, that ain't going to work. I go to them one last time. This time I'm pretty accurate. I said, you're going to have a bad shaft. It's not going to work. That's not providing the bear that we need. You don't need to pour until you fix it. At that time he looked at me. I was up in the mountains. He said, you see that rock? He said, go get you a pencil and piece of paper, sit on that rock, watch me how to pour shaft. I'll take notes. So I go over and I sit on the rock. I let him proceed with the pour. I didn't do it out of spitefulness. I mean, I done everything I could do. Honest to goodness, I lifted the gun to his head and told him I was going to blow his brains out if he elected to pour, and he'd pour it anyway. It happens to all of us. So, you know, people come out and say, why did you let him do that? You didn't let him do it. You done the best you can do. Sometimes you can lead a horse to water and he ain't going to drink. You might want to drown him, but he ain't going to drink. But it happens to all of us. So he elected to pour. I told him before he poured, we're going to run the CSL test. He starts pouring, and we get done, and 7 days later we run the CSL test. 100% loss in the bottom, 3 or 4 feet of shaft. Took him 2 months to fix it. 2 months to fix it. And you know what? You know, I had my, you know what, grin. But bottom line is, yes, I was right, but the project was delayed for 2 months. And, you know, I wish I could have done, you know, probably at hindsight, you know, I could have suspended it. But, you know, you try to make them do the right thing, and sometimes they just won't do the right thing. Again, I'm aiming for the barn door, and hopefully we hit the barn. So, but anyway, that's the story. This is what happens when you have bad shaft. CSL comes back bad, you have to come out, and you tell them, you know, you got a bad shaft. What do you want to do, Mr. Contractor? Well, the first thing he's going to tell you is, well, the CSL tube debonded. Jason Crawford is the world's worst for that. A long foundation. CSL tube debonded. Well, Jason, no, I was there, and this is what happened. I saw it. I saw this. This is what I think. That's what your documentation is for. You being there tells us why we think we got a bad shaft. See what I'm saying? Because that's the first thing they're going to say out of their mouth. I've done nothing wrong. But if you documented it and told us what's going wrong, that's when we're going to come back with it. He's going to shoot 1 bullet, we're going to shoot 5 at him. Okay? So he comes out, he drills a hole in the middle of the shaft. Anyway, actually takes the core out. The bottom half you can retrieve nothing. Mainly it's just sand, gravel, just nothing. So he's like, okay, what do we need to do? I said, we need to propose a method of repair. Comes back with hydro, demolition, and gravel. And Wayne, you've seen that. That's a pain in the tail, Wayne. Pain in the tail. They come out, drill port holes, hook up, pump grout in, anyway, it's a long drawn out process. We rerun the CSL test to make sure we got a good shaft, yada, yada, yada. But it takes about 2 months to get it done. I mean, 2 months. Long drawn out process. So, but again, documentation, your observations, if we're not there, helps us get to this point. Okay? Anybody know what that is? Anybody want to take it again? Huh?
Rock, come on.
A rock core, exactly. That's good. That's good. If you start seeing something like that, I don't care if you are at elevation that the rock's supposed to be, call it. Because if we got that type of quality of rock, we might can raise that shaft up. Because if you start getting cores out like that, we got some quality rock. Got some quality rock. I'm full of stories, and I always hate to tell bad stories. I went up to the mountains. We hit rock. Anyway, we had a hole that was going to be a 25-foot rock socket. I mean, hammer, ring, and tombstone, granite, cave rock. I tell the inspector, I said, stop at this elevation, drill your test hole. If it drills good, stop, drill the rest of them that way. For some unknown reason, he tipped that hole, he done his test hole. He was advised to tip it out. He tipped the hole out. Went to the next hole, tipped it out. Went to the next hole, tipped it out. So we paid for about 20 foot of rock that we didn't need to on each hole. I'm going to tell you why, but you make the phone call. And I'll tell you this, inspectors, and residents and assistants might get mad. If they tell you something that sounds funny, call me. Call Darren. Okay? And then we'll call the residents, and then we'll talk to them, okay? But if you're being told to do something that don't sound right, call. Because they might not understand, okay? Okay? Here is what you like to see. You got a permanent casing here on the outside, it's down the rock with a nice, pretty rock socket. You see that? That looks good. I mean, that's what you like to see. Here, what you're seeing is a trimming pipe. Most of the contractors now go into this because we had issues. Most of the time, a contractor would come with a pump truck and he would extend his hose down to the bottom of the shaft, right? Well, if you had to break the inner cases and take them out, he would have to break his pump truck loose, then rehook, which means he was inducing air back through the pump truck, which means I would say we need to go over here, make sure that burps. You're seeing that air bubble come out from up. And, if I'm telling you that on the phone, you have no clue. You're saying Lee's crazy. Lee's going stupid. Because concrete ain't going to work. But what they're doing here now is trying to take that out of the equation. They can actually pump with a concrete truck in that trimming without ever having to break anything if they have to slip out intercasing. So that's good. The only bad thing about that is when you got a small diameter hole and a small cage and a big trimming like this, there's not a lot of room down there. So what that wants to do is when that concrete starts coming up, it'll want to push the rebar out of the hole along with the trim. And it won't let you keep enough head on that trim. So what you might have to do is have a traco set here, put his bucket on both of them. That's something you have to look out for. Another good thing to do there is when you got something like that small, pour it on a high slump. Anybody know what that is? Huh?
The concrete.
You know where that is? That right there is a shaft. That's a drill shaft. That's what, I think that's about 15, 20 foot down. I'll tell you what happened on this one. I was up in the mountains, get a call from the inspector, says, Lee, we're going to pour a shaft today. I said, well, I can't make it. Just let me know how it goes. Well, when he starts pouring, the inspector calls me, I don't know, about 20 minutes into the pour, he says, Lee, he says, we got the trimming hung. I said, okay, we got trimming hung. That's happened on, basically on occasion. Not a lot, but it does happen. I said, well, just continue to pour. I said, the concrete's going to flow out and flow up. Everything's going to get pushed up. When you get it to the top, overflow it, cut your trimming pipe off and fill it full of concrete. Should be okay. No problem. Well, probably about 20 minutes later, he called me back and said, Lee, we got some major problems. I said, what we got? He said, we got a blob of concrete coming through the middle of this cage right here. It's cut off. It's set up. And I'm like, well, we got problems. We got problems. I said, we need to abandon the pool. He's like, well, I think that's what the contractor's going to do. At that time, the contractor calls me, the prime contractor calls me, and says, Lee, I'm abandoning the pool. I'm abandoning the pool. We're going to rip out the rebar, fight out the concrete, start again tomorrow. I said, I think that's a good idea. That's why he cut the steel off. Well, no, wait a minute. So he hooks to the steel, starts to try to yank the steel out. Can't yank it out. And what we determined was that the first load of concrete flash set in the bottom of the hole. So he couldn't get his steel out. At that time, he told the drilling man, says, we need to abandon this shaft, we need to get it out as much as we can. So he cuts the steel off. And he was going to go inside of the steel with a smaller auger, slide it down, cut the rebar out, drill down to where it was still green. So we was just about this close to getting that done when the owners of the drilling contractor said, we're not doing nothing. We're not doing nothing. He said, we got a good shaft. We got a good shaft. So to make a long story short, we run a CSL test. Well, the CSL test, for those who are familiar with it, only goes across the tube, right? But what we were concerned about is that the concrete flash set was that the concrete wasn't getting outside of the spiral steel, on the outside of the cage. So when you get up above that point of fixity that Dean was talking about, the fence post, and the shaft won't bend, you got to have concrete on the outside of that. So we were concerned about that. CSL test didn't show us that. So we told him that CSL test don't mean nothing. You need to provide to us that we got cover on the outside of that steel. Well, he flies in a testing company from California. The only place that does this type of testing is called gamma testing. He comes in, he runs the gamma test. We still have concerns with the results of the gamma. So the contractor, he's still hell-bent on keeping that shaft. Still hell-bent on keeping that shaft. And again, we're basing all our information to him, us standing firm that this shaft is bad based off what the inspector was telling me on the phone what was going on. And he's like, well, what can we do now? And all of us are talking at this time, and I'm like, well, you can expose the shaft. So he digs this shaft out, which is what he's done here. Dean Harster, which is out here this morning, goes up here on the inspection. Luckily for him, came back to where it was something we could accept. Luckily for him, that's a good shaft. I say for the contractor. But, everybody's like, well, man, I ain't never going to do that. The inspector's like, well, I ain't never going to do this again. And I'm like, no. I said, we could have dug that out, and it could have been a hole there. We could have drove a car through. I said, we don't know. And this is a stage construction bridge where you only got 2 piers on this stage. So if we wasn't sure that was a good shaft, and we turn traffic over there, and we don't have nothing on the bottom half of that shaft, and that thing goes like that, I mean, can you imagine what could happen? So I never, ever hold that against him for us getting to this point. He done what he was supposed to do. Now, if we lose in Raleigh, so be it. We'll go down there, we'll walk into that room, and we'll walk out with our head held up high because we've done our job. But I'll never fault him for what he done. But if he hadn't have told me about this, we wouldn't have got to this point. We wouldn't. So, guys, again, you are mine and Darren's eyes and ears out in the field. And if you see something and, see something's not going right, note it, document it, and call it, okay? Okay? This is slurry, but anyway, any questions, comments about drill shafts? I know I kind of got on the soapbox, but again, this is stuff that we see that is very common throughout the state. Don't take any offense if I use this as an example. But anyway, questions? I appreciate it, fellas.
we'll go ahead and cover the concrete testing and the aging of cylinders. And in getting ready for this, I sat down with M&T and talked to them about what's the most common things that they're seeing as far as problems. And what you're about to see is the results of our conversation. We'll talk about the concrete acceptance testing first. Somebody stated a while ago when Lee was talking about the drill shafts, the concrete truck drives on the job, what was the first thing you do? Somebody said check the job mix. Okay, mix design number. That happens. People are not checking it. So please check your batch ticket and compare it to your approved mix design and make sure they jive. That has been showing up according to M&T. And what we're talking about here is statewide. We're not talking about the divisions that are sitting here. And that is your batch ticket. Everybody seeing that correctly? Seeing it on your jobs? Everybody's pouring concrete. Okay. M&T Form 312, which is your approved mix design. Is the residents getting that out there to you in the field? Got some head shaking now. Okay, people will wait. The new M&T 250. And please note, down here at the bottom, I don't think you can read it with this overhead, but the batch plant is supposed to send you a partially filled out copy of this on the first load. On the last load, you're supposed to get the completed copy on the last. So please keep that in mind. If you're not seeing it, let us know. Let your concrete tech with M&T know. Let somebody know. Your resident, assistant resident, will dive into it a little deeper. One of the things that M&T talked about was not sampling enough concrete to perform the testing or make the cylinders. If you got to make on your first load, you're going to run the slump, the air, and all that. You don't want to go up there to the truck with a 2 or 2.5 gallon metal bucket, do you? That's not enough concrete to run all those tests. And they don't want you to go over off the ground and pick up some you discarded earlier to make it up, to finish out your molds, to finish out the filling up the pot for the Forney air meter. So get enough when you sample it, get enough to do what you need to do. Remember to check temperature of the concrete in the air. It's not showing up on the batch ticket. If it's not on the batch ticket, it doesn't get on the HiCam sample card. If it's not on the sample card, it doesn't show up in HiCams. So it just leaves a long trail. The reason that this is important is we're supposed to be doing it when we're making cylinders and et cetera, but we just come out of winter, did we not? A lot of the batch plants use heated water to make their concrete mixes in the wintertime. If it's heated water, what's the minimum temperature of the concrete mix? 55. 55 to 80. So that's another reason we got to check and make sure that the concrete's within specs. And if it's not heated, 50 is the minimum. Other items to remember, they're talking about these Forney air meters that they need to be calibrated more often than what you're doing. I kind of asked for a better description, and basically for the Forney, they just said it needed to be calibrated monthly. And when you do your calibration, write it down on a piece of tape inside the lid of your container, because like if you're the PI on the structure, hopefully you're not the one running the test, you're the one out there on the deck, and other guys are running using your equipment. They got the information there with them. Air entrainment admixture being added on the job site. I've seen this on a couple of jobs, and we've kind of got into it with the plant, but you run the test, it comes up 2.5 flash mix. This is a good example. And we're doing a deck, it's being pumped, it comes out 2.5%. The truck, well, if you're doing a deck, the rep's probably there. You tell him 2.5, he goes and gets so many ounces. And if you don't say something, he's going to want to just pour it right out of the bottle or whatever he's using right into the back of the truck. It needs to be put in a bucket with a gallon of water and then put in there. One job, they was doing it incorrectly, and I happened to have the concrete tech from M&T there, and I pointed, and he was like a bulldog. There he went. I didn't even have to tell him. He seen it himself. So, but the thing is, how many times can they add air to one? Just your first load of concrete, the air is low. How many times can they add it to that truck? Sometimes they'll almost get to where they can add it 3. One time I had to jump in and say, no, we can't add it no more. But a good rule of hint, though, if you have to start adding air in the field, if the concrete rep is there, I'd make him run the test before you run another pot. We don't need to run 12 pots to get one load of concrete in there. Other items to remember, don't let the contractor rush you. Pick on Lee there. He was just talking about if you're doing drill shafts, you check the slump, you check the chase, and then you need to make the cylinders before you go down to the hole if you by yourself. But still don't let them rush you. And I got some pictures of why in just a minute. The other thing is be sure and record all the information on your batch ticket, because the batch ticket helps generate the sample card. The sample card helps generate the information in Hykins. And if we have problems with cylinders or concrete, we need all the information we can get, because can somebody tell me about concrete they poured a month ago? Can you remember what your error was? There's a good reason. Another thing is stick to the rules of acceptance. If the mix design says 3.5 inches slump, stick with it. If you got to go outside the box, document it. Write it on the batch ticket. Write it in your diary. You got to document it. It could be that it's July, and by the time you get another load, you could have a cold joint. But I probably would make another set of cylinders just for that load, to be sure. The making of cylinders. One thing they have found is that the people making the cylinders are not always certified. How many people in here are certified in concrete? Better raise my hand. Okay. If you got a deck pour or anything, or even making pour and drill shafts, whoever's making the cylinders, make sure they're certified. They have to be certified, because if they're not certified, the cylinders are just for information only. We can't use them for a sticker. And also they noted, and this has come up on other projects, and cylinders must be made within the 10% and the 90% of the load. They can't be made in the first 10 or the last 10% of the load. So the thing about it is, you got to run your test. Once you get it, you know it's acceptable, let them start pouring, and then get your sample to make your cylinders. And we'll get to another example of why of that in a minute. Concrete cylinders should be cured correctly, protected from freezing temperatures, and kept from drying out. That's what we do to the concrete in the forms on the bridge deck. We're doing all that. The cylinders have to go through the same process, because if these things break low, there could be some concrete penalties with it. In other words, pay reduction, which is money. Cylinders should be delivered to M&T no later than 72 hours. It used to at 7 days, if everybody remembers correctly. But now M&T has the target time of 72 hours. And that's so they can get it in the curing room and get it under ideal conditions as quick as possible. So please keep that in mind. And please be sure and check them for a final set before you throw them in the back of your pickup truck. We have some cases where concrete has been what we'll call put to sleep, and it's one inspector went in there and grabbed a cylinder, and when he grabbed it, it squished. This was the next morning. And of course that cylinder's no good from then on. Here are some pictures, and please think about if you're making cylinders in a hurry, much less if you really don't care what they look like when you're done. But what do you think happened here? Yep. Of course, the only person that really knows is the one that made them. And when Lee was talking about his drill shafts, make your cylinders before you start your pour. that's true, but you sure don't want to go through it too fast to where you end up with they're not being stored correctly and all that. You have leaning. I think these were made in Cameron's area up in the mountains. I don't know. They on a tilt. But M&T had a turn. This is just a small speck of water in the bucket of pictures that M&T had of bad cylinders. They definitely have a Kodak if y'all haven't figured it out yet. What do you think happened to the ones on the right?
They made them at a slant, they were not level.
I ain't figured it out yet, but it looks like the concrete went on up into the lid. Now, how did that happen? Yeah, it had moisture to it, and it fluffed up and muffined on them. And again, you can see that the sides look good. It was rotted, tapped lightly and all that, but boy, they lost concern when they got to the top. The one on the right, I have no idea. M&T couldn't explain where that picture come from, but I asked him if it was a picture after the compression test was run. And of course, the one on the left, you can see it looks like part of the concrete went up in the cap. So when they fill up a mold, they're filling up the mold. And to me, the right side is kind of a good reminder that if your cylinder molds are wore out, don't use them. Your RE can get more from M&T because the cylinder mold it won't last too long if it's used a lot. And again, it looks like we're going into the cap, don't it? It's full. Sample cards, again, as Lee was talking about with the drill shafts documentation, and again, you have to document everything on your batch ticket. We was talking about adding air. If you add air, put it down on the batch ticket. If you had to add it once, or if you had to add it twice, put it on the batch ticket, because if there's problems, M&T, if the cylinders break low at 28 days, they're going to do an investigation. And that will be there for them to say, may not be the sole reason, but may not have nothing to do with it, period, but it's good for them to know. And again, make sure that all the information is on there. Another problem that they talked about is the representative quantity on the sample card. A good example is how many cubic yards in Class A concrete for a bridge deck does one set of cylinders represent? Can it represent? Up to, say it louder, 100 cubic yards. So if you got 3 deck pours to complete a deck, and your first pour is 80, don't write down 100. It has happened. That was actually an example that happened in the field. Write down 80. Also, if that cylinders had broke low to enough where we would have applied a penalty, it would have been based on 100 cubic yards, not 80. The question is about doing all the testing and everything is, are you being watched? Does anybody in here think that the contractor, subcontractor, or concrete supplier is watching you? Absolutely. Because we had some down in division, well, I'll leave it blank, had some 28-day cylinders break low. And the prime was informed that a penalty may be coming, may not, but be prepared. He let his supplier know. Supplier said, they didn't make the cylinders when they're supposed to. They made it right at the beginning of the load. You're being watched. You want the contractor to do what he's supposed to do, we in turn have to do what we're supposed to do. It's not a one-way street. So please make sure you follow our NCDOT policy for concrete, which is what they teach you in concrete technician class. And again, make sure that your your numbers on your batch ticket are matching your approved mix design, sample enough concrete, check the temperature of the air and the concrete, and keep your 40 calibrated monthly. And the air entrainment cannot be added more than twice to a single load. And was it added correctly? If you don't watch that added correctly, they will, well, you'll see the driver come out with Mountain Dew bottles of air and just start pouring them in the back if you don't say anything. Fill out all your batch tickets. So good, again, as Lee was preaching with drill shafts, documentation, and accept the concrete in accordance with DOT policies. If you go out on a wild limb, it's hard for us to support you. If the maximum slump is 3 and you put it in at 6, you better have some documentation on why you done so. Cylinders made by a certified technician. Remember that the cylinders can only be made between the 10% and the 90% of the load. Don't make it at the beginning and the end. Stored in a safe location. Make sure they don't get hit by equipment. Should not be moved for a minimum of 20 to 24 hours after you make them. And they must be kept at a temperature of 60 to 80 degrees. How many people are using a cooler to help keep their, got 2 hands? That's a good thing to do. Another job I got, the contractor made them a big old box insulated. That's good. But we got to protect this. If you're pouring a cap or a deck or whatever and you're protecting it with insulation blankets, we better be protecting the cylinders. Transported to the lab no later than 72 hours, and make sure they achieve the final set. Pop the cap off and see if they set up before you pick them up. And one of the things that M&T did bring up, you poured yesterday, it was cold last night, you got blankets on the deck. You get to the job site this morning, you said, well, I'm going to check my cylinders. They're hard. You said, I'm going to take them to the office so I can get that over with. So you take them out from under the blankets. What do you do with them? A lot of people put them in the back of the truck. Good examples, then they leave the project, say, well, there's a project over here. One of my friends, the inspector, I'm going to run over here and talk to him, and then they're sitting outside. So put them up front in the floorboard or something. Keep them warm until you can get to the office. Questions? Okay, we'll take a 10-minute break. Be back at 25 till 3.